Okay, boys and girls, we continue our lesson. Okay, today we will learn chapter 4 regarding the turning effect. Okay, wait, let me check. Okay. Okay, boys and girls, today new topic talking about turning effect. Okay, we call it as moment. Okay, turning effect we call it as moment. Year 9 we already learned about this. Okay, so right now we'll learn much more challenging question. We use this concept to solve more challenging question in our uh, year 10. Okay, so boys and girls, making something to turn. Okay, we will have a pivot point. Pivot point actually is a fixed point. So you can imagine you're holding a ruler, then one of the part, the pivot part, you using one of your fingers, hold it. Then another hand, then you push it down according to the direction of the force. Then you will find that your ruler will turn. So for moment, actually moment got direction. It can be turning clockwise or it can be turning anti-clockwise. Depends on where is the force you acting and where is your pivot. Okay, so this one also the same. We pull the force, at the end it turn. Okay, so turning effect we call as moment. How we count the moments, how big of the moments we caused by our force. Okay, so at here we understand that the force have to times perpendicular distance. Of course, some of you will using F times S, doesn't matter. Okay, distance can be using D or distance can be using S. In year 10, another topic we'll learn about work or energy. Okay, if work and energy also using force time distance, but that one is slightly different with what is the distance we're talking to. Having quite similar formula, force time distance. So we need to separate out by using different May or S. I using this because in future we learn about work, it will be using symbol of S. Okay, here there is one keyword. The distance. Where is the distance? Perpendicular. What is the meaning perpendicular? 90 degree. Okay, so from where to where the distance we have to use. Okay, dear, I teach you. Okay, you using your ruler. Okay, ruler. Okay, you pointing parallel with your force. Okay, so at here you move this ruler parallel with the force. Okay, to until the pivot here. Okay, then after that we draw this line. Okay, we draw the line which is parallel with our force. Okay, the distance between these two lines, this is the distance. What is the distance we need to find? Okay, dear, the distance is perpendicular distance of the force, 90 degree to the force. From where to where? From the force until the pivot. This is the distance that we want to find. Okay, so what is the unit? As I told you, we study physics, we study smart. We cannot everything memorize. Okay, that one is biology. We don't need to memorize. From the formula, we can know the unit. Okay, so the force is in Newton. Distance, if SI unit, distance must be in meter. But as long as the question doesn't asking for SI unit, this is SI unit. SI unit is the standard international unit. Okay, so if the question doesn't specific have to give me in the SI unit, then it's fine. We can using Newton system. Question, there is a button for you to create the reaction. So I know that we can proceed to the exercise. So this is theory. Okay, Teresa, okay? How about this? Okay, so fine. Okay, come here. Okay, I want you using the technique that I teach you just now to find out what is the moment. If I want to find the moment, can you tell me what is the moment? A, B, C, D. You can type your answer in the chat box. The distance is X or distance is the Y? Any of you can tell me? 紫花 no. 紫花 no. Let me see. Emily. Emily correct. How about others? Tell me your answer. Wrong also never mind, dear. Megan correct. Yeah, yes, 紫花 correct right now. Okay, dear. Using the technique that I teach you just now, okay? So you using your ruler, okay? Put on the force here. Then you move this parallelly until your pivot. Teresa, correct. Okay, until your pivot. So you draw a line at here. Where is the distance? Distance is between these two lines. So your distance actually is x. You see, 90 degree. 90 degree to the force from the pivot. Pivot is the point that it fixed, fixed. It cannot move, okay? So at here, our answer should be A. Okay, test you again. Another past year question. Can you try and tell me which distance we should use to find the pivot? Yes, correct. 直花 correct. Perpendicular. That is the keyword. Zihua no. Megan no. Teresa correct. That means that Teresa get the idea already. Megan correct. Megan correct. Okay, dear. Let me have a look. Okay, dear Zihua, look at me. Put your ruler, okay, along the force here. Okay. Then you move this ruler parallel to until the pivot. Okay, so at here, where is the pivot? P is your pivot. You see, pivot is at P. So you move this ruler, move until P point at here. So you draw a line. Distance between these two lines, which is your A. This is your perpendicular distance. See, perpendicular, dear. Perpendicular. Get the idea? Yes, right now, okay, So, okay. Teacher, why we need to learn about movement? Is it helping in our life? Of course, dear. Okay, we goes to your page number 3. Okay, is it okay? Page number 3. Okay, moment. We got principle called principle of movement. Principle of movement said that when a body is in balance or equilibrium, okay, or you saw the word like they stay horizontal, that means that balance lah, doesn't move here and there, doesn't turning clockwise or anti-clockwise, okay? So at here, if the system, okay, if the system or body is in parallel, is in balance, then the sum of anti-clockwise moment must be equals to the clockwise. Anti-clockwise equals to clockwise, okay? So you look at this diagram. This is seesaw, okay? So we hang two objects at here. So one of the object on the left-hand side of the pivot. So at here, I told you, you're trying to using your ruler. Okay, you're using one of the right hand. Okay, you're using your right hand finger holding this pivot. Do not let it move. Then you're using your left hand, push another side of the ruler going down. How it turns, dear? How it turns? You will find out that it will turn in anti-clockwise moment. It will turn in anti-clockwise, okay, anti-clockwise. So the moment at here is anti-clockwise moment. Okay, W2. Put your ruler here. Left hand side, your finger holding the pivot point. Do not let this point to move. Then your right hand push the ruler down. You'll find that your ruler turning in this direction. Okay, so it will turn this direction. This is clockwise. So our anti-clockwise moment must be equals to clockwise moment. So force time distance, W1 times the D1. You see 90 degree from the pivot. Okay, from the force until the pivot. Okay, then clockwise moment is W2 times the D2 times the distance. if they can be balanced, we say that the system is in equilibrium, or we say balance. Okay, net moment. What is the meaning of net moment? We learn about net force, right? Net force, we got so many force. At the end, we find a single resultant force. Okay, that is net force. So for moment, also the same. I got two moments. I plus minus them to find out the single moment, that is called net moment. Because this moment equals to this moment, at the end, the net moment is in zero. It's in zero, okay? So we look at here for this diagram. Okay, first diagram. Anti-clockwise moment. The child and the girls, okay? The child at here, it will turn anti-clockwise. Do you able to agree me? Okay, agree with me this point? He turns anti-clockwise. So the girls is turning clockwise. I want you to count anti-clockwise moment. Force times distance. The boy is 200 times the distance. Which distance we use? The distance at here actually is 1.5 meter. Okay, so at here, how many? 300, is it? Yeah, 300. Unit Newton. Look at the distance that we use. We are here writing meter, so this is Newton meter. Okay, how about the clockwise moment? Okay, so look at here. The girls is 300 Newton times 1.5. So at here, my answer, I get 450 Newton meter. Okay, boys and girls, can you tell me that in this body or system, is it balance system? Equilibrium? Does it equilibrium or balance? Let me have a look. No, Teresa said no. Okay, this one at the end, it will turn in clockwise moment. Because clockwise moment is 450 Newton meter. This is greater moment than the anti-clockwise. That means that we got extra 150 Newton meter to make it turn clockwise. So at the end, it turn in this direction. It doesn't balance. It doesn't equilibrium. It doesn't balance. So at here, so this the seesaw is not balanced. Okay, not balanced because anti-clockwise moment and anti-clockwise moment not equals to clockwise moment. Okay, so at here, second diagram. Okay, second diagram, we adjust a little bit. Of course, at here we saw the girl is more heavier. Okay, more heavier. If let's say you goes to the you go and play with small kids, but you always the boy or kids is always on top, then you're always at here. It's not fun at all. You're trying to adjust a bit until it balance. So at here, you see the 300 Newton actually is a bigger force. If you want to create back the same moments, the girl actually adjusts to make the distance become shorter. Okay, why need to do so? Okay, for the anti-clockwise moment is here. Is 200 times 1.5. So we're still getting the 300 Newton meter. So for the kids, it doesn't change. Okay, the moment doesn't change. For the girls, 300 times, it make the distance shorter. Shorter, that means 1 at here. So we get back 300 Newton meter. So can you see that if your force is greater force, you want to get back the same 300 Newton meter, then you need to make force increase, then you make your distance shorter lah. Okay, can you see that actually in this example, 300 Newton meter and 300 Newton meter, at the end we understand that anti-clockwise moment equals to clockwise moment. So in the second diagram, the seesaw is balanced. Okay, until here, do you have any question you want to ask me before we proceed? Yes, Zihua, because shorter, yes. Why shorter? It's because the girls are heavier. Okay, the force at here is greater. So in order to balance and get back the 300, she need to make the distance become shorter in order to balance it. Okay, boys and girls, let me show you about this. Okay, I need you to think, if let's say I put my 5 kg at 2, actually this one is ruler lah, okay? If no ruler is something like this, okay? I put a ruler so that we can be more easier to understand where is the distance, okay? What is the distance? Okay, boys and girls, if I remove the support, it will turn anti-clockwise. This is anti-clockwise, go back first. Okay, you look at it, how it turns anti-clockwise. Okay, I want you to think, if I want to put a 10 kg, okay, if I want to balance, I put 5 kg, I should put at 2 meter here. Then it will balance back. Okay, it will balance back. Now my question is, if I want to put 10 kg, any of you can let me know where should I put my 10 kg? Yes, Zihua, correct. So Zihua, you get the idea about the just now the question diagram B? Yes, good job. Okay, let me have a look. Teresa, no. Emily, correct. Teresa, you have to check. In order to get back the same moment, where should we put the 10 kg? Okay, yes, correct. Zihua, correct. It's 5 times 2. Actually, it's 5 times 9.8. Then times 2. Because 5 kg is in mass, dear. So if we're talking about moment, we should using the force times distance. So the correct way actually is 5 times 9.8 times the distance is 2. So we need to get back the same moments. We should put the 10 kg at 1. So we have a look. Yes, correct. Okay, so boys and girls, is that clear about the moment? In this condition, we say that the system is in balance. It doesn't tip to any side. Okay, this is called balance. So we continue our lesson, goes to the next page. Okay, for page number 3, is it okay? Can we proceed to page number 4? Okay, Teresa, okay. Angeline, okay, okay. Angeline is our new friends. Okay, here. Megan Zihua, okay, good job. Right, dear. Balance. Condition for balance. Do you still remember that before we learn about today's lesson, we're talking about the force. We also saying that if the system is in balance, your net force should be 0. Still remember? If the system is in balance equilibrium, then your net force should be 0. Okay, we look at the first case. Here, how many force acting on the system? Okay, the pivot here pointing upwards to support the beam. Okay, so we got 2 upward force, which is 2 Newton and 3 Newton. So write down 2 Newton plus 3 Newton. Total upward force is 5 Newton. Okay, so what is the downward force? Here we only got one downward force in the diagram, which is 5 Newton. Okay, so can you see that this system is in equilibrium? It's because the upward force equals to the downward force. So if they are equals, we find the resultant force. Actually, we found out that upward and downward, they balance and cancel out. So net force is 0. So this one, we learned it already. Okay, we already learned about this. So we said that when the force is in balance, okay, a net force is in 0. The motion for the object, it might have two. One is object at rest, which is the case that we're mentioning right now. Okay, object at rest, or maybe object moving with constant speed. Okay, previously we already learned. Today we add one more point, okay, which is when the object is in equilibrium, not only force is in balance, but resultant or net moment also 0. So we look at this case, 6 times 4. So it's 24 Newton. Be careful with the unit of distance. It might be cm or m. So at here is m. So we write m, Newton meter. Okay, clockwise. This is clockwise label. Okay, clockwise. Any of you don't know how to differentiate the direction, determine the direction, have to let me know. Because this, if you don't know how to identify the direction of the moment, then it will be a big problems for today's lesson. Okay, my suggestion is put your ruler, pivot, you holding with one of the finger, then you follow the force direction, you push it down, then you will know. Look at your ruler, how it turns. Okay, so for this one is 8 times 3. 24 Newton meter. We found out that anti-clockwise moment equals to clockwise moment. So actually your net moment is 0. So condition for the equilibrium. Resultant force 0, net moment 0. Any question? It might be saying net turning effect, net moment, resultant turning effect, resultant moment. They are the same thing. Okay, if no question, we try with the partial question right now. Okay, the diagram shows a uniform meter rule. Okay, P is your pivot, two weight W1 and W2, okay, at the either side of the pivot. The ruler remains balanced. Highlight this. When they remains balanced, we must follow the rule, principle of moment. Okay, which rule is correct? Question number 1. Teresa correct. How about others? Emily. Emily correct. Megan correct. Zihua correct. No problem, right? It's easy. Okay, resultant moment. Resultant force. 0. Okay, we goes to your page number 5. Okay, here. First step that I want is you have to determine the direction. Direction. 6 Newton is anti-clockwise moment. Anti-clockwise. F is clockwise. Okay, what force is needed to balance? Keyword balance. If you saw the word of balance, we have to follow the rules. Anti-clockwise moment equals to clockwise moment. Okay, try it and tell me your answer. Wow, Emily, not bad. Very good. Zihua correct. Hui Tong correct. Teresa, Angeline. Shuan. Let's go. Wait lah. Shuan correct. Megan correct. Crystal, finally you are here. Just now I take attendance, I didn't saw you. Okay, answer is D. So 6 times 4 equals to force times 3. So your force should be 8 Newton. Okay, so this one is easy, right? Okay, we go to the next question. Question number 3. The problem is the force that acting on the beam doesn't at the either side of the pivot. Now pivot is on your left hand side. Okay, can you try? Can you try and tell me? So first step I want is you determine the direction of movement. Is anti-clockwise or clockwise? Okay, they want to keep horizontal. So highlight this keyword. Keep horizontal. That means that anti-clockwise moment equals to clockwise moment. So determine. 20 Newton. First determine 20 Newton is clockwise or anti-clockwise. F is clockwise or anti-clockwise. Okay, can you count what is the magnitude? Magnitude, that means value with unit, called magnitude. Okay, so what is the force needed in order to make the beam stay in horizontal? Keep in horizontal, so it's in balance. Megan, no. Megan, no. Megan, try. Crystal, correct. Zihua, correct. Angeline, correct. Xuan, correct. Okay, dear. 20 Newton is clockwise, right? Okay, ruler. So this one hold it, then you push it down, it will turn in this direction. Okay, the force at here, F, this is your pivot. If you push your ruler upward, it will turn in this direction. So this one actually is anti-clockwise. For the F is anti-clockwise. Okay, how to determine using the technique that I teach you using the ruler. Okay, so at here, anti-clockwise moment must be equals to clockwise moment. The force times the distance equals to the 20 Newton times the distance. Ask yourself, what is the distance? Okay, dear, the distance is 90 degrees from the force until pivot. So I should using 2 meter as my distance for the force. Then 20 Newton is 1.2. Your answer for your force should be 12 Newton. Any question? Megan, do you start at any point or right now do you clear about this? Yes, okay. Then we try with the continue to your page number 6. Okay, we go to page number 6. This is answer A. Page number 6. Okay, the diagram, which diagram is not in equilibrium? That means that they are not follow the rules that we mentioned just now. Net force is not zero, then net moment is not zero. Like boys and girls, try it and then tell me which one is not in balance. That means it will tip to one side lah. Wow, Emily, correct. Hui Tong, correct. Teresa, correct. Megan, correct. Crystal, correct. Good job. Their answer is C. Correct. Okay, here 3 times 2, 6. 6 times 1, 6. 6 times 2, 12. 6 times 2, 12. Okay. This one 3 times 1 is 3 Newton meter. This one 3 times 2 is 6 Newton meter. Of course, it's not balanced. It will tip to this side. C is wrong. Okay, but how about D? How about D? Okay, so here 4 times 2, I get 8 Newton meter. Okay, for another side clockwise moment, I got 2 force. How should I do? Some of the students, you would think that I add up the 4 Newton plus 2 Newton, 10 times the distance. Wrong, it cannot. So what should we do? 4 Newton times, from here to here is the distance causing by the force. So it's times 1 plus, I got 2 clockwise moment. 2 times the distance. What is the distance? The distance is from the force until the pivot, which is here. So my distance for the 2 Newton, it should be 2 meter. So at the end, 4 plus 4, 8 Newton meter. This is balanced. D is balanced. But of course, we already know C is wrong lah. Okay, until here, any question? Any question there? No question, then we goes to the next question. Is it okay? Teresa, okay, Others should be fine. Okay? So dear here, two people X and Y sit on the seesaw. X is 400 Newton. Sit at 1.5 meter from the pivot. The weight is for the seesaw is 300 and acting on this pivot. Okay, here when the seesaw is balanced, okay, balance, the pivot push up on the seesaw with a force at 900 Newton. What is the weight for the person Y? The weight is always pointing downward. Weight is always pointing downward because weight is caused by gravity. Force due to the gravity. So it's always pointing downward. Okay. So boys and girls, can you try? What is the weight for the Y person? The problem is, teacher, I want to find the clockwise moment equals to anti-clockwise moment. But the problem is I don't know the distance for the person Y. How do I know the weight? So use another rules. When they balance, they got two rules. So try and then tell me what is your answer. Angeline, correct. How about others? 智化 correct. How about others? Where are you guys? Okay, downward, upward force, we got 900. How about downward force? I got 400 plus 300, and I got the weight for the person Y. From here, I can know what is the weight. Emily, correct. Your weight should be 200 Newton in order to balance it. So 200 Newton we need, okay? So this is the first rule. Second rules, we say that net moment equals to 0. That means that anti-clockwise moment equals to clockwise moment. Okay, so at here, I know that my weight for Y is 200 Newton. Okay, at here, dear, at here, 400 Newton is anti-clockwise moment. 200 Newton is clockwise moment. There is one problem here. You might be asking me, teacher, then how about the 900 Newton and 300 Newton? Is considered clockwise or anti-clockwise? My answer is, if the force is exactly acting on the pivot at here, is there any perpendicular distance? No. My answer is no. There is no perpendicular distance. So that means that the 900 and 300 Newton, it doesn't cause any turning effect. We can just ignore the force at here. Okay, so clockwise, anti-clockwise moment is the 400 times the distance for the girl is 1.5. It's 1.5 equals to clockwise. So for the boy is 200. So 200 Newton times the distance. This is the distance that we want to find. It's 1.5 or 3.0. So at here, what do you think? Answer A or answer B? Okay, so we need 3.0 meter, right? Answer is B, right? Okay, deal. One thing that I want to emphasize at here. Can you see that? If you are having a bigger force, then you will get a shorter distance. If you having a smaller force, then you need to have a larger distance so that you can be balanced. Is that clear? So I know that this 200 Newton, in order to balance, I cannot 1.5. I need to more than 1.5. Is that clear, dear? If clear, then we go to page number 7. Is it okay? Crystal, okay. Can you remember? Okay, Teresa. Teresa, for this force, is it okay? For this part, is it okay? This part okay, so I explain for the second part. Okay, dear, it's like that. I want to find the distance. I want to know what is the distance for the boy Y until the pivot. I know I want to find this distance. Okay, so at here, um, we need to determine where is your anti-clockwise moment, which is caused by the girl. This is anti-clockwise moment. So for the boy, it's closing the clockwise moment. For the moment, is the force times perpendicular distance. So whatever force acting on the pivot here, they don't have perpendicular distance. Perpendicular distance is like this. It don't have perpendicular distance. Doesn't have. So in order to calculate moment, whatever the force acting on the pivot, we don't need to count because they doesn't give any moment, doesn't give any turning effect. So the only thing that you need is only these two. It's actually the diagram become much more simple, which is like this. Okay, so we got a 400 Newton acting at here, another 300, 200, 200 Newton acting at here. Okay, now what, in order to balance it, I need to know where should I put my 200 Newton? Where should I put my 200 Newton? I want to find this distance. Okay, so at here 400 is turning in this direction, then another 200 Newton is turning clockwise. So at here, I just using the 400 times 1.5. Here is 1.5 meter. Then the 200, we want to find this distance. Distance from the pivot causing by the boy. Okay, how far from the pivot? So at here, after do calculation, we found out that the boy need to be stay at 3.0 meter. Until here, Teresa, is it okay? I need here as 3.0. So Teresa, until here, is it okay? Or which part? Teresa, until here, okay. Now, the things that I want to emphasize is you can find out their relationship. 400 Newton is bigger force. It just giving a short distance. Then, if in order to balance for the smaller force, you need to adjust yourself to have a greater distance so that you can get back the same magnitude of the moment in order to balance it. So 200 Newton, of course, is lighter than the 400 Newton one. So in order to balance it, no choice, have to move further away from the pivot. So we can using the 200 times 3.0 to get back the same anti-clockwise moment. So Teresa, is it okay? Okay, Lydia goes to page number 7. Okay, the diagram show a child and an adult. Okay, the seesaw in the diagram is balance, equilibrium. Tick the box alongside any correct statement. Okay, which one is the correct statement? Hmm. Teresa, half mark. Emily, correct. How about others? Zihua, correct. So deal. Seesaw imbalance. Imbalance. So which one is correct? They're trying to confuse you. They didn't say any correct. Yeah, okay. They give 1 mark. Most of the time we'll think that maybe only one answer. But here the answer should be both of them. Resultant force is 0. Resultant turning effect is 0. Both are correct. Okay. Moment of the child about the pivot. This is child. Okay. So B asking you to calculate the moment for the child of the child. Can you try and tell me? Teresa, but I want unit. Exam no unit, I didn't give any mark. I need formula, substitution, and final unit. Final answer with unit. Correct. Angeline, correct. So this is the child. It turning anti-clockwise moment. So at here, the moment for the child, it should be the force times distance. The force caused by the child is 300. Distance until pivot is 1.4. 1.4. So your answer should be 420 Newton meter. This is the answer for question B. Okay, question C. Can you calculate the weight of the adult? We want to know W. Can you do calculation right now? Emily, correct. 3 marks, dear. Can you see that? 3 marks in the question. So you need to give formula, substitution, final with answer. Correct. Okay, dear. So at here, uh, C. Okay, C. In order to balance, anti-clockwise moment equals to clockwise moment. So 300 times 1.4 equals to clockwise W times 0.6. So your W should be 700 Newton, dear. Newton. Don't write Newton meter, because today we learn about moment. So I need to write Newton meter. No, this is weight is one type of force. The unit is in Newton. Okay, so answer is C. Okay, D. Question asking you, state what would be happen if the child moved further away from the pivot. Right now, this diagram is showing you they are in balance. Now, if the child move further away from the pivot, can you tell me what will be happen? The child move further away, more than 1.4 meter. What will be happen? Nothing happen. It's still balanced. Any of you? Child move further away. If the child move further away, the child's turning force. Not turning force. It's not force. Child's force doesn't change. Child's force turning what? It's not turning force. Teresa, yes, but you have to explain it more. It's and the clockwise force, no, dear, not force, dear, not force. The 300 Newton force, it doesn't change. The child move further away, force doesn't change. Crystal, correct, but you have to explain in more detail. It is unbalanced, correct. What will be happen? Yes, Zihua correct right now. Okay, dear. Okay, dear. Look at here. Just now, Zihua say turning force. I keep on saying no. Force doesn't change. The correct answer is turning effect. Okay, moment. Okay, moment. Or we say turning effect. If you mentioning about force, no matter if further away, the force still 300. The changes is actually the turning effect. The turning effect move here. So you are times that, let's say it's times 2, it becomes 600, it become greater. Greater anti-clockwise moment. Greater anti-clockwise moment. Okay, so seesaw will be falling to the child, correct? Can? The seesaw will be tip anti-clockwise, correct? Okay, so here, as long as you mentioning the child's side will be goes down. Okay, the adult side goes up. We say child's turning effect is greater or correct. Okay, so at here, child's moment is larger. Okay. So we say child side goes down. Okay, so here is okay. We goes to the next question. Next question a bit challenging. Starting to give you some challenging question for the next question. Okay, we come here. This is the past year question saying that holding the weight 120 Newton, the 20 Newton force is the weight of the forearm acting at its center of mass. Okay, the F is the force due to the muscle. Then P is the point, pivot. Okay, P is pivot at here. P is pivot. So in this question, P is pivot in the elbow. The distance of the force all are showing here. Okay, by taking moment about point P, that means point P is pivot. Okay, point P is pivot. Calculate the force F. Okay, so at here, this one, let me have a look. Holding, like there, holding. Holding, that means that not move. It's balanced. Okay, so first, this is the pivot. Okay, this is the pivot. So the force at here, you have to determine F pointing upward is clockwise or anti-clockwise. 20 Newton, 120 Newton, clockwise or anti-clockwise. First question, how we solve the question? Anti-clockwise moment equals to clockwise moment. So look at the diagram. First step, determine the direction of moment. Then you solve it. Then tell me what is your F. Emily, your answer and my answer slightly different. Is it some value you substitute wrongly? Checking again. Determine the direction first. What is your answer? What is the force that I need? Yes, Zihua correct. Clockwise must be equals to anti-clockwise. Yes, Crystal correct. Crystal correct. How about others? For question A, anti-clockwise moment equals to clockwise moment. So anti-clockwise is due to the F. Clockwise is due to the 20 and 120. Emily, correct. Angeline, correct. So at here, the force times the 2 cm. Why I don't need to change in meter? As long as all the distance that I use is in cm, then it will be fine. Okay? So at here, I times 2. Because from the force until pivot, this is the distance that I want. Okay, equals to the 20 Newton times force until pivot, which is 15. Plus 120 times from the force until pivot, which is 33. Look at here, from here until here. This is the distance, 33. Okay? So at here, if you do it, press your calculator wrongly, everything mathematics is good. Okay, 2130 Newton. We will make our answer in 2 to 3 significant figure. So this is answer A. Okay, answer B said that there is also one force acting on the forearm at the point P. They tell you there is one force acting at point P. Can you calculate what is this force? And tell me the direction. Can you try how to solve and find the force due to the point P, acting on the point P? Know how to solve? Holding equilibrium. So two rules we need to apply. Anti-clockwise moment equals to clockwise. In question A, we already solve and find the F. We already find out 2130 Newton here. Then, second B, asking about the force. What more rules we can use? Crystal, no. Direction is not distant because it's acting on pivot. It's not asking you distance. It's asking you the direction. Is the force is acting upward or acting downward? Teresa, so it's upward or downward force? Megan, correct. Like dear, you guys look at me, for the B, how we solve? We can using upward force equals to downward force. Net force is 0 lah, dear. Okay. So at here, ask yourself, how many upward force at here right now? Which is 2130 Newton. Right now, I still don't know P is upward or downward. We still don't know. But I know that upward at here is 2130. So here, 2130. Got any others force? I don't know yet, okay? How about the downward force? The downward force is 20 Newton and 120 Newton. So at here, 120 Newton first. 20 plus 120 Newton. This is the force, So right now, in order to balance the both sides, the one more force acting on point P, it should be upward or downward. Ask yourself, I want to balance here and here. The one more force acting on point P, it should be at downward side or upward side. What do you think?
Upward.
Upward, very good. It should be at upward here. So the force acting on point P should be at, sorry. Am I saying upwards? It's downward, dear.
Downward.
Downward, okay? So at here, downward. So at here, the force acting on
Gravity.
point P, how many? It should be? What is your answer? 1990 Newton. So for
2130 minus 140.
pardon, 2130 minus 140. Yes.
Okay.
Okay, deal. So at here, what I want to say, let me think. Okay. So actually, basically, this topic is just using two concepts. Either is we using the principle of moment or we using the balance force concept to solve it. That's all. Okay. No matter how the force and the pivot they change, you must be clear how the force is acting, which direction it's acting. Okay, we go to your next page, page number 9. Okay, any question? Can we go to page number 9, dear? Yes, Teresa, okay. How about others? Angeline, Megan, Emily, okay. All okay. Okay, let's go. Okay, this is a good question. This is a good question. Question number 8. Okay, so we have a meter rule, pivot at the center, which is also position of its center of mass. 3 load, 2 Newton, F 3 Newton. Okay, our position at the 20, 30, 90 cm marks on the ruler. Calculate the moment of the 3.0 Newton load about the pivot. It just want to know about moment of 3 Newton. It's not asking you the whole system. Every time my student, they will just look at the question. They didn't really read it carefully. They're just trying to using the principle of moment, solve everything and define F. No. Right now it's asking you moment of the 3.0 Newton. So can you count and tell me what is your answer? Wow, very good, Angeline. Yes, correct. Emily, no. Moment. Some more moment is not Newton, Teresa, correct. But it's not 270. Okay, dear. Here 3 Newton. So it will be clockwise moment. Okay, moments for the 3 Newton is equals to force times distance. So at here, the force is 3 Newton. What is the distance? This is the very important things we need to determine. Zihua also know. Okay, why no, dear? Where is the distance? The distance is from the force 90 degree, from the force until pivot. This is the distance that we want. What is this distance? 40 cm. Excuse me. Okay, 40 cm. So 120 Newton cm. Here, there is a trick here. Okay. So dear, next, calculate the moment of 2.0 load. Okay, they want to know about this moment. Can you try and then tell me? Correct. Oh, Teresa, deduct your 1 mark. Teresa, you know why I deduct your mark? Angeline, correct. Teresa, do you know why I deduct your mark? Dear, have to deduct your mark. Kristen, no. Kristen, no. Distance, maybe did you calculate distance wrongly? Emily, correct. Zihua, correct. Megan, correct. Okay, dear, here. Okay, the moment for the force times distance, 2 Newton is the force. Distance. Where is the distance? From the force until the pivot. From the 2 Newton until the pivot here. So what is this distance? This distance is should be 50 minus 20. 50 minus 20. So you get 30 cm. The distance in between is 30 cm. So you should times 30 cm. So it's 60. Teresa, why I need to deduct your mark? Unit is Newton cm. Newton is force. Newton meter is wrong. It's because here, can you see that we are using cm for the whole question? It should be 60 Newton cm. Oh, Crystal, wrong. Crystal, wrong. Unit wrong. Dear, unit wrong. So you will lose the mark. Okay, dear, next. Okay, the force F maintain the meter rule in equilibrium. Calculate the F. So can you see that here is 120 Newton cm. This one 2 Newton giving you 60. That means that we still not balance it. I still need to using another one more F to balance it. Okay, so can you try to calculate and tell me what is the force that I need for the F in order to balance the system? Angeline, no. Maybe distance you substitute wrongly or what? Check again. Any of you can tell me your answer? Angeline, correct. How about others? My dear, tell me your answer. How about others? Emily, no? No? Almost there? No? Why all of you giving me answer 2 Newton? It's not 2 Newton. Angeline, can you tell me why 2 Newton? How you guys calculate? But at the end, you second answer is correct. But I want to know why you guys calculate 2 Newton. 3 of you are giving me 2 Newton. I want to know your idea. Why at the end you get 2 Newton?
Miss, is it 3?
Yeah, 3.
Oh, okay. 3.
But they giving me answer 2 Newton. I want to know what is the problem? Why they calculate and get 2 Newton? Question number 3. Check your answer and then later on you guys tell me why you get 2 Newton. Anti-clockwise moment equals to clockwise moment. I got 2 force causing anti-clockwise. So which is the 2 Newton? Just now the 2 Newton we already count 60. 60 Newton cm plus the force times the distance. Here the distance is 20 cm. 20 equals to the clockwise. Clockwise at here is 120. Okay, we already count in question 1 and 2. Because you use the wrong distance value. You using 30? What value you use? Is it you using 30? So at here, if you do it calculate correctly, it should be 3.0. I want 3.0. Instead of 30, I want 3.0. Two significant figure. Okay, dear? Final answer give me 3.0. Okay. So is that clear for this question? Okay, Crystal, okay. How about others? If okay, then we proceed to the page number 10. Can we? Yes, Okay, here. The weight of the ruler is 1.2 and then now it's considered to act at the 50 cm mark. All the weight in A are removed. The pivot is positioned under the 30 cm mark and the 2 Newton load is placed on the ruler. Okay, the position of 2.0 Newton is adjusted until the meter rule is balanced again. Can you determine the positions of the 2.0 Newton? Try and then tell me. Where is the position for the 2.0 Newton? Look. Wow, very good, Angeline. Yes? How about others? Normally, this kind of question, most of the students only can score 2 marks instead of 3. Zihua, no. No, Zihua, no. How about others? Crystal, no. Same thing, what, dear? Anti-clockwise moment equals to clockwise moment, right? So anti-clockwise moment equals to clockwise moment. Anti is 2 times what is the distance? We don't know. Okay, clockwise is 1.2 times what is the distance? Don't put 50, dear. Just now we do the exercise, we already understand. We want to find the distance between the force until pivot. So what is the distance at here? 20 cm. So I put 20 here. Then calculate what is the distance. What is the distance from here to here? What is my D? So at here, your D is, you should get 12 cm. Am I right? We should get 12 cm. Okay, Megan correct. If you stop at here, give me 12 cm, you will score 2 marks only. Because the 12 cm that we count actually is the distance from the 2 Newton until the pivot. This is 12 cm, not 20, 12 cm. But this is not the, we haven't finished answering the question. Determine the position. Where is the 2 Newton position? Okay, so boys and girls, from here to here is 30 cm. Until pivot is 30 cm. Where is this point? On the ruler, it should be showing. So you should using 30 cm here, hold 30 cm minus 12 cm. This is the position on the ruler. So it should be 30 cm minus 12 cm, 18 cm, 18 cm mark on the ruler. You're only able to score 1 more marks. It's asking you where should we put on the ruler, the position, how many cm mark. Okay, is that clear? If clear, then we go to next page. Any others? You want to ask me any question? If no, then we go to the next page, next question. Okay? Okay, Crystal, okay. How about others? Emily, Xuan? Huh, dear? No response. Can I proceed? Or you want to ask me any question? Now the distance that we find is here. The mark on the ruler. So here should be 18 cm. This one should be at 18 cm. Here should be at 18 cm. Plus the 12, that's why I get 30. Can I proceed? No response. How do I know whether you get the idea or not?
Yes.
Okay. Yes, okay, next idea. Wow, this one no longer like directly give you the forces and the distance. So you have to think what distance you should use. Okay, first question here, calculate the moment of the weight of the ladder about point B. Dear, about point B, that means that point B is your pivot, your fixed point. Weight is always pointing downward. So at here, the weight is 240 Newton. Weight is always pointing downward due to gravity. Okay, calculate the moment. So your weight is your point B. Point B, okay, here, dear. This is your pivot. 240 Newton. Moment is equals to force times distance. The weight is 240. What is the distance I should use? 3.2 or 1.2? 1.2, thank you. Like dear, 1.2. Why 1.2, teacher? Dear, can you see that? The technique that I teach you. Parallel. Then distance between them. This is the distance between them. 90 degree. Can you see? 1.2 is the distance for 240 Newton. Okay, so at here, your answer should be 290 Newton meter, because this question in meter. Okay, I want to ask one question. Can you tell me that this 240 Newton is clockwise or anti? Clockwise or anti? Any of you can tell me clockwise or anti? The 240 Newton is clockwise or anti-clockwise? You have to determine. If not, later on another question you can't answer what? Clockwise No. Dear, it should be anti. Why, teacher, anti? Put your ruler like this, dear. Put your ruler like this. Put your ruler. Okay, then this point is a fixed point, B, fixed point. There, using your finger holding the point B, then the 240 Newton pushing. So you try to push your ruler downward. How it turn? It will turn in this direction. This is anti-clockwise. So Crystal, okay? Anti-clockwise. Okay, here there is another force called F. Okay, here cos F here, it will be cos clockwise or anti-clockwise. Again, the ladder. Here is the fixed point. Push your ruler. How it turns. It will turn in this direction. Your ruler will turn in this direction. Do you agree? Do you agree? No response. How I know you get an idea or not? Okay, here. In terms of F, that means that your answer will have the words of F lah, okay? For the moment of F about point B. F moment, they want to know F moment in point acting on point B, about the point B. So at here, in terms of F, because we don't know what is F what. So in terms of F, your answer should be have F inside lah. Perpendicular distance, so it should be this 3.2. We should times with 3.2. If you want to using the technique that I teach you is put your ruler at here, parallelly move, so until the pivot move. So the distance between these two lines, that is your perpendicular distance, 90 degree. So at here, what is your answer? We should force times 3.2. Okay, so we should be 3.2 F Newton meter. 3.2 F or F times 3.2, doesn't matter. Okay, until here, is that clear, dear? Use your answer in A, so it should be in A lah, in A. Okay, can you calculate your force? This one, use these two answer. This is the anti-clockwise moment. This one is clockwise moment. Anti-clockwise moment equals to clockwise moment. So can you tell me what is your F? Correct, Angeline. Okay, so at here, the anti-clockwise is 290 equals to 3.2 times F. Your F at here, I make two significant figures, so I get 90 Newton. So if you are 3 Newton, should be Angeline answer 90.6 Newton. I didn't count for that. Okay, if three significant figure, yes, it's 90.6 Newton. Okay, So at here, you see why I need to teach you how to identify the distance. It's very important. If you know the technique, you're only able to solve this kind of question. You see the force direction is different, but doesn't matter. Although different direction, but you take it out and then you're using your ruler to determine the direction. The most important is to you able to identify clockwise or anti-clockwise. That is a very important keyword. Oh yeah, if too significant, it should be 91. Yes, so true. So if you do calculation, is it 90.6, dear? Then it should be 91. Okay, then 91, dear. Okay, next. Explain why they must have an upward force acting on the ladder at point B. They tell you that actually at point B, pivot, they also got a force acting upward. They're asking you why. Why they must have the upward force. Any of you can try? Why? Do you know that? Just now we said that here, highlight the keyword rest. Rest, that means that balance, equilibrium, balance, right there, balance. So we got two things. One is net force is 0. Second is net moment is 0. Then why I need to have an upward force? It's because it needs upward force to make it 0. What 0? What 0? If you say it need an upward force to make a resultant force become 0, okay. But if you only say need upward force to make it 0, the
Can
answer
say
not complete.
can say it needs upward force to make it an equilibrium.
Can. To make the ladder in equilibrium, can. But if you only say upward force to make it 0, I don't know what is the 0 you want right now. Unless you tell me that to make resultant force become 0, then yes. Okay, they must have an upward force. Because there is a downward force, the weight downward force. We need to balance it. Okay, so one of the answers is to balance the weight. Okay, then we can say that to make resultant force 0. Okay. Okay, or you say to keep the ladder in equilibrium. Okay, it's fine. Okay, is that clear? Can we go to the next question? Next page, page 12. There is a downward force, of course, it will have an upward force because it's at equilibrium system at rest. At rest. So we need to have a resultant force is 0. Okay. So is that clear? If okay, let me know. Then we can proceed to the page 12. Can you react? Or you ask me question? No problem, Angeline. It can be 2 to 3 significant figure. It can be 2 to 3. Most of the time I use 2. If the answer have to carry to the next question, then I will use 3. I use 2 is because most of the time if we study the IGCSE answer scheme, most of the time they are using 2 significant figure. So, by the way, it can be accept 2 to 3, no problem. Okay. So there we go to the next page, page 12. Okay, in simple problem like just now, we always assume that the weight of the bar we can ignore. Okay, but in some of the complicated problems, they want to trick you, they want you to include the weight by yourself. Okay, so just now all the question we didn't consider the weight lah, and they even we consider the weight, they will label for us. Okay, so we need to know right now. Further, one more knowledge is we need to know where is the weight. Okay, for a uniform meter rule, if you saw uniform, that means that the weight will always acting at the center. At the center. Let's say now my meter rule is 100 cm. Where is the weight of the meter rule? It should be at 50 cm. Okay, it will be at the center. Okay, if this is not a uniform, if this is not a uniform bar or whatever, okay, it's not uniform, so where is the weight? The weight will be acting on the center of mass. If not uniform, they should tell you where is your center of mass. They tell you center of mass, then I know that my weight will be acting at this point. What is the center of mass? Center of mass is the point that the weight will be acting on this. Weight will be acting on this point. Okay, so at here we're having a look by this question. You see the diagram show a beam laying on the ground. The NQ is lift from the ground by the force P. MP is remain. So P is pivot lah. Okay, P is pivot. The length is 3.0 meter and the weight 600. But in the question, they doesn't label where is your weight. So in this question, we have to label it. Okay, we have to find where is your center of mass. In this question, they tell you center of mass is at G. So we label this down. This is 600 Newton. Weight is at here. They didn't label, but they want us to label it by ourselves. Okay, so at here, we want to lift it up. Just able to lift it up. So at here, we still following the rules. Anti-clockwise moment equals to clockwise moment. Okay, so at here, 600 Newton. This is P is pivot. Okay, here, 600 Newton. This is clockwise moment. Then force is anti-clockwise moment. Okay, then here, anti-clockwise should be the force times what is the distance, and 600 Newton times what is the distance. Always ask yourself, from the force until pivot, what is the distance? Here is 3. 600 from the 600 Newton to the pivot is 1 meter. So what is your force? Your force should be 200 Newton. Actually, this question is exactly like previous question that we did just now, but we only add on one more knowledge, which is the weight. Where is the weight? We have to label it by ourselves. Okay, any question for this? Any question, Dale? No question, Zihuan, no question. How about others? Emily, Crystal, Angeline, Megan, okay. Xuan, Crystal, okay, Angeline, okay. Just add on one more knowledge only, Okay, dear, these two questions, you label the answer at the bottom part at here. I worry we are unable to finish. Answer for question 2 should be C. Question 3 should be B. Okay? Then what I can give you some hints is, okay, for this question first, later on you try by yourself. Okay, the weight is 200 Newton. This weight, what is the direction? This is the pivot. This is pivot. So this one should be clockwise. The force exerted by the man should be anti-clockwise. Okay, then you can solve the problems. That is the hints that I give. Okay, then for this one, okay, I give you the hints, clockwise and anti-clockwise. So you're using your ruler, something like this. This is the fixed point, pivot. Okay, the weight pointing downward. So you push your ruler downward. Then you'll find out that your ruler will be turned clockwise. Okay? So next, what is the keyword that I can tell you at here is, this one, center of beam. Center of beam 100 cm uniform. So that means that from here to here, it should be 50 cm. Okay? Then, if you want to find the distance, here quite complicated, this question. 8 Newton until pivot, what is the distance? Do you know what is the distance? 8 Newton to pivot. Do you know what is the distance? Any of you know what is your distance? If I want to count the moment for the 8 Newton, what is the distance I should use from 8 Newton until the pivot? None of you can answer me, dear? This question we do it together. I worry you guys cannot solve. Megan, correct. It should be 50 cm. Why I know? From here to here is 60. From here to here is 50. How I know this one is 50? Again, center of beam for uniform. This one is 100 cm long. That means total length for the meter rule is 100 cm. Where is the center of mass? It should be at 50. At 50 cm, half of the meter rule. So I know that red color here, I know from here X to center of the beam is 50 cm. Okay, then here to here pivot is 60 cm. Okay, then using your mathematics minus the 10 cm, so I get 50 cm. Okay, here 8 Newton, 8 Newton, it should be a clockwise, anti-clockwise, sorry, anti-clockwise. Center of beam is the weight, which is 4 Newton, 4.0 Newton. Here, they tell you meter rule. Weight is 4.0. So this one is also anti-clockwise. What is the distance between 4.0 until the pivot? Any of you can answer me? 4.0 until the pivot. What is the distance? Angeline, correct. Crystal, correct. 10 cm. How I know? Mathematics 60 minus 50. So I know this distance is 10. Okay, what is the force here? Force here is clockwise moment. It will cause clockwise moment. Okay, from the clockwise moment until the pivot, what is this distance? Tell me, mathematics. Okay, correct. Thank you. 20 cm. Dear, here. Anti-clockwise moment equals to clockwise moment because they say keep balance, okay? So anti-clockwise, I got two. One is from the 8 Newton plus 4 Newton equals to the force times what is the distance. So what you need to do is please determine what is the distance here and what is the distance here, distance here. Always ask yourself from the force until the pivot. From the force until the pivot. So 8 Newton times what? Tell me. Can you count and then tell me the answer? Correct. Angeline, correct. Then continue. 4 Newton. Okay, so 8 Newton should be times 50 cm. It's because at here, from the force until the pivot, this is the distance. Okay, how about 4 Newton? 4 Newton until the pivot. So what is the distance? 10 cm. Then the last one, the force. Force until pivot. I'm using different color to show you the distance that I want to find. So this one 20. What is your force? If you do your mathematics correctly, you should able to get the answer 22. Correct, thank you. Angeline, thank you. So dear, this question, the most important, actually got two things. One is, do you know that where is the weight? Weight always at center of mass. Where is the center of mass? If they say uniform, then it will be exactly at half of it. So this question telling you uniform beam. So 100 cm, then half of it is 50 cm. That is your weight, 4 Newton. Okay, then second is they didn't give you the distance directly. They need you to using mathematical way to find it. But the most important is from the force until pivot. From the force until pivot. From the force until pivot. Okay, so at here, I'm using different color. Can you see that? Differentiate it out. So this one is 4 Newton. Then this one is 8 Newton one. Is that clear? Okay, done? Okay. So dear, third question, I give you hints already. Actually, nothing too difficult. It's just like you need to find the distance correctly. So perpendicular distance using the technique that I told you, like this, like this. So this is perpendicular distance. So this one, okay, like this until here, this is your perpendicular distance. So for the force here, what is the distance you should use? You should using actually 15 plus 45. Okay, I want you try to solve it. The answer should be B. If any of you cannot solve it, then you come and WhatsApp me. Then I print screen the working set for you. Okay, I want to go here. Question number 4. You write down the final answer. Okay, A. Okay, what is the weight? Wait, this one have to draw first. Here, uniform. You see, uniform iron bar, 3.0 30 Newton. But they didn't label where is the weight. So 1.4, that means that half of it. It should be your weight, 30 Newton. Draw an arrow to show the weight of Barbie. So we show it up. This is the center of mass. Where is my center of mass? It should be at half of it. So it should be from here until here, half of the beam bar, which is the 0.7 meter. Okay, like boys and girls, you label. Okay. So next, what is the one? What is the question one? State the distance d of the center of mass of the Barbie. Center of mass of the Barbie, where is it? From the pivot. Okay, second question, state the distance of the center of mass of bar B from the pivot. From the center of mass until pivot, the stone is your pivot. It's the point that it doesn't move. So what is this distance? They ask, what is this distance? Any of you can tell me what is this distance? What is the distance from the center of mass until the pivot? The stone is the pivot, Megan, correct. You should using 0.7 minus 0.2, mathematics 0.5 meter. If you cannot solve, it's not my problem, dear. 0.7 minus 0.2. This is your distance, mathematics. Okay, next. Calculate the total clockwise moment about pivot on the Barbie. Barbie. Okay, pivot and clockwise. Okay, clockwise. How many clockwise moment at here, dear? I got 30 Newton is clockwise, 40 Newton also clockwise. Can you find it out for me? What is your total clockwise moment? Always remember, it's from the force until pivot. Distance for 40 Newton. 30 Newton, just now you already count 0.5 meter. Can you count the total distance? Not total distance, total clockwise moment. Angeline, deduct you 1 mark because you give me the wrong unit. But answer is correct. Unit is wrong. Total moment, yes. Okay, deal. Total moment at here, C, question C. Okay, moments. I got two. One is from the weight. One is from the 40 Newton. Okay, so at here, 30 times 0.5 plus 40 times the distance. This distance should be 1.4 minus 0.2. So it should be 1.2 meter, 1.2. So your answer should be 63 Newton meter. Always be careful with the unit. So I'm using the highlighter. This distance until 40. Okay, until the pivot, dear. Until pivot. Then I'm using another one, the weight until the pivot. This is the distance. Is that clear, dear? Is that clear? The total clockwise moment is caused by two forces. One is 30 Newton, one is 40 Newton. Is that clear? Can I proceed? D, they say that downward force, calculate the downward force. Okay, acting on the end of bar B. Okay, there is a downward force. In order to balance, you see, I already got two clockwise moment. In order to balance, I need to have another anti-clockwise moment. So my downward force should be on another side at here. Okay, they're also telling you at here lah, okay? So at here, my downward force, I got a downward force. They're asking you what is this downward force? F. What is this F? So this one easy because it's balanced what dear? It's balanced. So at here, the anti-clockwise moment equals to clockwise moment. The anti-clockwise moment is the force that we don't know until the distance, and clockwise is just now what we calculate here, 63. Now the question is force time what distance? Force time what distance? So force times the distance until pivot. Force times the distance until the pivot. So at here, this one should be 0.15 Newton. Is that clear?
Yes.
Is it okay, dear? Okay, good job. Last, suggest a change to the arrangement that will reduce the force required to lift the slab. So at here, I want to reduce the force. I push it down, but I don't want to using 40 Newton. Can I reduce to 35 Newton? How? Okay, how? Any idea? If here, just now we say, if here distance decrease, in order to balance back, then your force decrease, then your distance should be increased. How to increase this distance? How to increase this distance? You can move your stone going to your left. Move your stone at somewhere here. Then from here to here, the distance increase. So I can use less than 40 Newton. So the answer for the last question is, okay, move stone to the left. This is one of the answer lah, okay? Move stone to the left. So boys and girls here, I repeat one more time. I don't want to using 40 Newton. I want to reduce this force. And maybe I just want 35 Newton. Okay, if I decrease the force, in order to get back the same force, not force, same moments. So anything I can do, I can trying to move my stone slightly to the left. Why? If I move my stone to the left, I will increase my distance, perpendicular distance. So after that, I times it back, I will get back the moment that I want. Using smaller force, then you have to, if you want using smaller force, then you increase the distance from the pivot. Is that clear? Any question, dear? Okay, if no question, then we will end our lesson today. Next week, I will give you new lesson. Okay, I will give you a new lesson. Lesson number 13 is a short subtopic only. I try and save and edit the document, but it say I need a password for it. Save and edit. Angeline, later on you WhatsApp to me.